Hi friends, welcome back to another installment in the series The Raytracer Challenge, where I implement a raytracer from scratch in Rust, a language I am learning while implementing this raytracer, and you can follow along. The structure I'm following is from this book, The Raytracer Challenge by James Buck. You will find links in the description below to the GitHub repository containing all the code we are creating here, as well as a link to the book itself should you be interested. So what did we do the last time? Let's have a quick look. We implemented planes, another body type, which allows us to have a plane struct which is infinite in 2 axes and therefore is ideal to, for example, provide a floor or walls or something like that for our rendering. Let's have a quick look at what we did last time here and how this looked actually by simply running our bin chapter 09 here, which was the last one we did, in release mode, and have the raytracer quickly render our scene. We are ray tracing now our scene with a plane in it, so let's open it up and see what we got here. And as you can see, this was the result. The last time we have this plane as a floor which is infinitely extended into the Z and the X, and therefore is a perfect floor here where all our spheres are lying upon. Furthermore, we have shadows, which we implemented in the session before, and we can now go along and implement the next step in our ray tracer, which would actually be the implementation of patterns, as I said the last time I had this session here. But in the meantime, I decided to do something a little bit different from the book, which would allow us to be a little bit more flexible and have easier management of those scenes. If you remember how we define our scenes, it is always here done in code. We are defining our light structs here, we are defining our materials here, we are defining our body types like spheres here or planes here in case of the new body type plane. And then we are putting everything together in this world struct. We are then creating a camera here which looks at this world from a certain perspective. And then we are actually going along and running all our rendering code. What I was thinking is that we could have it a lot easier during our work and scenes if we could simply supply all those information, all those transforms and those materials and structures, essentially everything that makes up our world in a different descriptive format, which is not Rust code in this case, from the outside, so that we could reuse it from chapter to chapter to chapter. And that's why I went ahead and implemented a WorldLoader. So I've created this trait here, which is quite simple, as you can see. It only has one method it needs to provide. And it has a result type we will take a look at in a second. It has this load world function, which goes ahead and takes source, some sort of string source actually here, and it returns a loader result. And the loader result actually is a world object, and it is a hash map containing of a key value mapping between strings and camera objects. So we could essentially have more than one camera and therefore render more than one output. And what I then did and went ahead was I implemented, or played around, better said, because I've never done this before in Rust, I've implemented a YAML-based loader. Even though for most situations I don't really like the YAML format, but in this case I think it might be quite nice to have a definition of this kind. I've written a test here to see if my YAML loader actually works. And the YAML should look something like this. The document itself is always a list of entries which are of different types, like we can have camera here, we can have a light here, we can have body types here, which then in turn have, of course, materials and have transforms and stuff like that. So let's begin at the top. We have a camera in this example scene here, which wouldn't really render something we could see actually. We will create this in a second because those are only test values for our parser here. The camera actually is defined by having a name, a width, a height, a field of view. So everything that we actually provide here in the, in the normal camera definition as well. So we provide this camera width, this camera height, the field of view, and so on. We provide information from where to look and in which direction to look and where is up and stuff like that. Then we provide a light, which is actually in our case a point light. We only have one light type currently, but as I've said a lot of times, we might change that in the future and add more different light types. So I have the type here encoded as well, and then I'm telling the light where it is and what color and intensity it has. Then we have one body in this case, which is of type sphere. It has a specific material, which is of type Phong. There is the same thing as with the light. We currently only implement Phong lighting or Phong materials, but we might implement others in the future. So I've already adapted our format to this. We are defining a color, diffuse, ambient, specular, shininess, all the things that we usually have here in our material definitions, as you can see here as well. Then we go along and have transforms, and every body has actually a multiple set of transforms. It could, of course, only have one of those entries if we only want one, but usually we want to transform our bodies in more than one way. We want, for example, as you can see here, to translate it in a specific way and then to rotate it a little bit or the other way around. And as it is with matrix transformations, those are, of course, dependent on their order. So if we translate first and rotate then, it is different than if we should rotate first and then translate. Yeah, and this is actually a way we could specify now a scene, or that's the plan actually. So as you can see in this test, I'm taking this scene here and then I am creating the exact same thing in our objects here with the world, where is one body with a sphere and a new Phong material with the given properties and transformation matrices. As you can see here, the transformation matrices are automatically applied in the reverse order, so that we actually have this, in this case, that the translation will be executed first and then the rotation will be executed, so that we don't have to think about that matrix multiplications are always needed in reverse order. So this is what the YAML parser here does for us already. And we are expecting a camera, which actually has this key of output 1, which is the name of the camera. And then we are defining this one with a proper H and V size, field of view, and yeah, I guess you get the point. And then we are assuming that once we have told the YAML loader to load the world from this source here, that then we actually have this world struct and camera out of it, which we can then directly use in our program to render and ray trace our scene. And if I'm now running those tests, you can see that they are actually, where is it? There, that this one is passing. So even though this is only a quite simple test, which definitely does not handle each of the cases, and there is no error test at all yet, I will add those after having recorded this session, because I don't want to bore you with creating tests now for something that you haven't actually really seen. I just wanted to introduce this concept of this file to you here. So now we are going to take a look at this parser, or it's more like a transformer, or a specifically said it could be named a compiler because it takes kind of an abstract syntax tree of the YAML, which I'm parsing using the YAML Rust crate. I actually researched a little bit, and I know there is something like SERDI, if I'm pronouncing this correct, the all-in-one YAML Rust serializer, deserializer framework, which has a lot of different formats it supports, like YAML and like JSON and like everything you can think of, more or less. But I thought this might be a little bit overkill. I'm not 100% sure if what I've done here is really effective or if it's the way to do in Rust, but I've played around with it a little. And what I've written here is a simple visitor of this, more or less syntax tree that our YAML parser creates for us. So we are always starting here with our load from string function from the YAML loader, from the YAML Rust package. And then we are getting back a bunch of documents because one YAML file could contain more than one document. So we are visiting those documents. And then there we see that in this case, we are tracking some sort of path here. So what I'm doing actually here is I'm tracking the path inside the YAML file. So where did I traverse into so that I can create proper error messages. If you have, for example, let's show you this. It is for having proper error messages, as I can show you. For example, if I am in this light object here, and I'm in this add property here, and I'm not providing a float here, but I am providing, for example, some string which wouldn't belong there. And now I am running this tests again. We should see that, we expected a float at value 0, which is actually the index of document 0, so the first YAML document in the file, as there could be more, which are delimited by those 3 minus signs here. And then root 1, which tells us index 1 of the root document. So we have index 0 here, that is the camera, and index 1, which is light. Then we are going down into the light property here, and we are going down into the add property here. And then there is some string which we did not expect. So there should have been a float. So that we get actually proper error messages. That is why I'm there introducing those path tracking segments I have done there. Let's make this test run again. Which we had here before. Where was it? Visit documents. There we are. So that is actually why I'm pushing those path segments here, and a path segment can either be a key or it can be an index. So we can either have a string key, like if you are wandering down the add or the lights or whatever, or if we are wandering down an array, we can have a key. We can have an index. So yeah, that is actually what we are tracking here, and this is why we have here some sort of macro which does this while executing the visitation. But what we are more or less doing here is we are telling to visit documents, then we are iterating all of those documents, and we are calling to visit the corresponding document. And once we are visiting the document, we are taking this information, and then we are using one of our functions to ensure that this one is actually an array, which we expect there to iterate. Then we iterate it again. Then we have all those items in there, like lights, camera, body, and so on. So are going to the visit light function. So it's a really, really standard and not really fancy iterator. Visitor, which simply walks down this tree and visits it with all its leaf nodes and gets all the values out of there. Like, for example, in this case, we are then checking if it's a light. Yeah, then we are obviously visiting a light value. If it is a body, we are visiting a body value, and so on and so on. And in the end, we are constructing then all this together. Here, where is it? We are then, after we have visited all of our documents and items and stuff, we are actually then putting everything together and creating a new world. with our bodies in it, with our lights in it. We are taking our camera's hash map and returning all of this together as this tuple of information we need to render something that we have already seen. The code here might be too complex at certain points, and I'm not 100% happy with how this functions yet. I might refactor it in the future a little bit, because I'm not, as I've said, I'm not 100% happy on how this is done here. I had to fight a little bit at certain points against the Rust compiler a little, because I've not done this before in Rust, and there are certain specialities that are not there in different other languages, as you know, in Rust. And yeah, that's actually here the case. One or two things I want to point out, which are quite neat, and I've learned while doing this. So let me have you learn those as well. First of all, what I did here is I was thinking about how to transport all of this information throughout my YAML parser. Because usually I would have done this in any other language, like, for example, with in a purely functional language, I would have piped it through in every function call, like in Erlang or something like that. But in a more object-oriented programming language, I would have put this in the object state of the parser. So I would have tracked all those information there, as I'm doing here now with a struct. So I have the current path. I have the current paths there. I have the already passed lights, the bodies, and the cameras, and they are added by the visitor at the moment they are encountered, and they are put in this state, and then therefore pushed through all the visitation functions to be available once they have been discovered. Essentially, this makes sense, and I implemented it this way first and then refactored it twice and did it in another way, because what I didn't like is that I now need to have, as we can see here, for example, with visit light, that we now always need a mutable self-reference, because we are adding a light there. So we are mutating our state, which is absolutely correct that we then need a mutable self there. But the problem with this is that where is it? My WorldLoader trait with the load world does not expect a mutable self, because why should it? It shouldn't expect that the thing that implements the WorldLoader trait changes its state because I told it to load a world, because it does not have or provide you with information about a state. So why should you assume it should change its state? It is a trivial function, so to speak, which takes an input and you get an output, and then everything is finished. There is no state in between which should be preserved or mutated while doing this operation. You wouldn't assume that this would happen. And you might now ask yourself, how did I do this? Because if my YAML parser always needs this mutable self, then how can this initial call not have a mutable self there, and the compiler not crying out? And the idea, which actually a friend of mine gave me, who is developing Rust a little bit more than me, was the following. He said, okay, actually you have something that should change state. It is the parser itself, because while it is running, it has a state and it should change state. But the parser itself should then not be the implementer of this WorldLoader trait, because the WorldLoader trait, or the WorldLoader, of course, does not have a state. Therefore, why not encapsulate all of this? And this is essentially what I did. I have this YAML parser, which has this state and is providing all of this stuff here and putting it through in a mutable way, so that all of those functions can update them. But I've then implemented a secondary thing here, which is simply called YAML here, or YAML loader I could have called it, but I've actually called it YAML only because it is here in the namespace WorldLoader. So And this one implements WorldLoader now. So we have this separate struct which doesn't have a state, as you can see here, and this is absolutely right. It shouldn't have a state. And once the load world is called, it is instantiating or creating a new parser, which is perfect because now we have encapsulated this whole state holding operation into the operation itself, and therefore it is semantically correct again. And now we can actually have this as a mutable, and then we can call parse YAML on it, and we can return the result, and everything is fine, and everything is happy. And this is a kind of thinking about encapsulation that I need to train when developing Rust, because I would usually not have done it this way. But it makes perfect sense to have this semantically encapsulated properties there and state there for this specific operation, and to have this encapsulated there in this mutable area here, and not further out by simply encapsulating it in another stateless struct here. That was one thing I learned. The other thing I learned, which made me crazy first, was where are we? For example, one of those, let's take a look at one of those utility functions here, which, for example, gets a specific index from a given YAML array. This is only to work with the YAML Rust data structures a little bit nicer and to provide proper error messages if there is something we didn't expect. So what we are actually always doing here is we are returning a parser result. And let's take a look at what a parser result is. A parser result, and this type is only a remnant of, I had before there a type which was like this. It was immensely long. Because I did something other than this, I didn't use the anyhow crate. And you usually can have you have something like you have a standard result in Rust, and this result can either be the result object, so it's then encapsulated. You might have seen it here. It's then this OK type where it is encapsulated, or it can have the error type, which is then encapsulated here with an error, and then you can either have the result itself, or you can have something that implements std error. STD error, I think, which is a trait, and you can implement it, and then you are implementing your own error. And I did this before, and I had, I don't know, 80 lines more code which implemented this error, which is fine. It's not that complicated, but these structs get really complicated really quickly because first I had this like something parser result t equals, this is by default, it's empty, and then I have something like result here, and then I had this this t here, and then what then followed was something like a box with a dynamic error, I guess was it, in there, and yeah, it got ugly real fast because now you had quite ugly types there, and the creation of such an error was ugly as well, because the problem is that we have those, which is really nice, we have those short circuit, where are there? Short circuit question mark calls here, which essentially tell the system to try to execute this, and if it's returning an okay result, perfect, give it to me. And if it's not returning, if it's returning an error, then simply abort the operation there, abort the execution there, and propagate this error one level up. So to the next one. So simply return it here. But this means that this one needs to be a type which, of course, is a result as well and can return this error. But the problem is that this error, which is created here, isn't known at compile time because the compiler cannot know it. So we need to put it in a box, and so it's only it's something that the compiler knows the size of again, because a box is only something that references something on the heap. And once we have done that, we then need to make sure that every error implementation would be accepted. So we are actually telling the box to only contain some object of a specific trait, and this gets horribly ugly quite fast. And those creation parts here where I created the errors then, like here for example, were like, I don't know, 8 or 9 lines encapsulated, like a box with a error in it inside a enumeration of error, and it got horribly ugly quite fast. And then my friend told me, hey, there is this anyhow crate. You can simply install it, and it more or less does all of this in wondrous ways. So let's quickly take a look at anyhow Rust crate. And this anyhow crate actually helps you with all of this and makes things so much nicer. So you can now easily use the, where was it? Like you can use this anyhow macro to easily create a new error out of thin air, out of a string. That's more or less exactly what you want, because you can, in a custom error type, attach further information, but you can actually do this with anyhow as well. So either you are creating the string because all you wanted to propagate was a proper error message. You can then use this anyhow macro here to easily create this, or you can create, and this is really nice, you can create on errors which are created somewhere another context. So which is really nice here is, like, for example, if you are going ahead and using fsread, fsread might tell you that the path you have supplied there is not, there's no such file. But if you only got those error message, if you only get this error message here, you wouldn't actually know where this happened. Okay, some file or directory could not be read, but where in your application and which file and which directory. So you can, with anyhow, just create a context here and put a context with it and say, okay, I've now attached to this error another context, and I've said failed to read instructions from some path. And then the error message actually gets a little bit more interesting, because now anyhow will stack up those errors and create some sort of information tree out of this, where you have something like your context, and then the level down was this specific error. And as you can see, this together is a lot more informative than only this one. And therefore, my friend told me, use anyhow for error handling, because it is so much nicer. And once you get to the point where you know that it exists, use it, because it makes so much more sense to do and makes things so much better and the world so much better while developing Rust. And what is very nice here is that it's sort of backwards compatible with the original result things, so that we can, where is our implementation there? So we can use the loader result, as you have seen, or as you can see here, is now an anyhow result. But we can still have our library here, which does not return an anyhow result, as you can see here, but a normal result with its own error, a scan error. But we can still short circuit out of here, and the system still works, and the error is translated correctly, and it is seen correctly. And this is the nice thing of anyhow, that is more or less transparent in 99% of the cases. And in the 1% it is not, you can easily work around it. But those are the things I learned, and yeah, please take a look at this code. It is of course in the GitHub repository, and if you are interested in this. But the two major learnings from creating this was this encapsulation of mutability and the usage of anyhow. And yeah, so I guess this is what I wanted to show you, which I've done in the meantime. But now, after I've nearly talked 30 minutes about what I have done in the meantime, but I still hope it was interesting to you, let's do something with this. So we should start now by creating some sort of, yeah, let's say executable here, which we can use to provide it a YAML file with a scene and then have it rendered. So I guess this is what we are going to do now. Let's first of all, why not copy this one as a starting point? Oops, no, that was not what I wanted to do. Let me insert this one. Why didn't this work? There it is. Copy. So now we could call it render YAML, I guess. Let's call it render YAML chapter, or let's stay with chapter 0 render YAML, even though those executables don't necessarily map to exactly what was happening, because I'm not even sure we can actually create some of the stuff we created before. For example, we cannot easily create something now without having shadows in it anymore, because shadow rendering and shadow raycasting is part of our renderer now. But I think I still want to have it this kind of way for now. We will see if we change this naming in the future. Let's start here by removing all the current world definition, which we won't need anymore, because now those informations will be extracted from our YAML. Of course, we now have a lot of unused imports here. So let's see, I don't think we need a lot of stuff there anymore, which is actually a good sign, I guess. Yes. Okay, so now we need to to maybe refactor this a little, but we will see. First of all, let's create a corresponding loader there. So let's have a YAML loader, WorldLoader YAML. Was it new or was it default? I'm not 100% sure what I implemented there. No. Okay, so WorldLoader cannot be import. Yeah, I want to import this, of course, and then this should be failed to resolve. Could not find in. Consider importing one of these. YAML. Oh yes, of course. We need to specify the correct namespace there. Yes, and I guess there was only a default implementation when I even did this. I'm not 100% sure. Yeah, okay. It seems I did this. Let's check what I did there, because I'm not 100% sure now anymore. What did I? Yes, I derived the default, which is quite okay, because we don't have specific properties in this thing that we need to set during creation. So now we have our YAML loader. So maybe we simply want to do it like this, and have WorldLoader like, yeah, I'm not 100% sure if we, let's see what this thing wants to import for us. I'm not sure if we need to import, yes, I want this one, the trait as well. We will see in a second, but I guess we will need to import the WorldLoader trait. So now we have our YAML loader, and now we could do something like let, and use destructuring here and say, okay, we want our world here, and we want our cameras, which are properly multiple cameras and a hash map, and we are taking this from the YAML loader here and tell it to load the world. And now we need the source somehow, of course, and we can I hope we can do this in a main function. I'm not sure, we will see, but yeah, it seems to me that this short circuit might be fine or not. Oh no, okay. So we will handle this error in a second, but now first we need to load this source information somehow. Let's for now simply create a string here, call it source. We will change this in a second, but so now we can take a look at the error handling, and then we will find out how we can load the information from a file which is given to us on the command line. Yeah, so I guess we are now taking a look at this one, and I guess our main can maybe simply return a result, which is An empty object by default. So let's return this here, an empty object. Oh no, yeah, empty object. I see. So this should work, and then and yeah, I guess we are now using this one from unwrap result return type. No, I want to import this one from anyhow, because now we are using anyhow. Use anyhow result, and this should be now an anyhow result, and this, yeah, it seems to work. So now we should be able to yeah, as I've said, now we can apply a context here, which in this case should be quite nice. And then we can have a question mark here. And is this not? No method name context found on enum result. Why not? Oh, we need to we need to import the context trait from anyhow. Yes. Perfect. And now we can provide something like, we could do format, and we can put in here like let's say tried reading, or tried parsing. There we are inputting the file now as YAML world definition, but failed. And then we are somehow source file. We will have to get this here as well somehow. Let's for now define it. Source file is empty as well, so it should work there. Now let's format this, and as we are now doing this shortcut here, if this does not work, and we will test this in a second when we are using it, it should actually bail out there and give us this information, which would be quite nice. So before we are taking a look at how to load those files, let's refactor the rest of this. So what we now need to do, of course, is we need, as we might have multiple cameras, we need to create an iteration here. So we need to iterate over our cameras. So for cameras, can I simply iterate a hash map? Let's take a look. I'm not 100% sure. So Rust a hash map. So what kind of functionality is there to iterate this? I guess I can iterate it in an arbitrary order, I guess. It doesn't have a fixed order, which is understandable as it is a hash map, but I think I can iterate. What do we get here? We are getting all values pairs in arbitrary order. The iterator implement is you are getting a key and a value. Perfect. So we are getting a key and a value reference. So we can for name dot comma camera in cameras dot iter. Should work. Yeah, we are getting those two references. Nice. So we can now put all of this stuff in there, because for every camera and every perspective we want to render one image now. So let's auto format this. Okay, so now we are creating a new canvas with the camera.hsize and camera.vsize, which is quite nice. Then we can do this here as well. Vsize multiplied by camera.hsize. Wait a second, did I do this here right? No, I did not. I have the horizontal, or did the horizontal? Yeah, the horizontal is the width. Okay, then I did this one in the wrong order here, but it's the same result anyway. Okay, so then we could output that we are ray tracing. Yeah, let's output more information here now. Let's have ray tracing camera, or let's camera, and then the camera name there with the amount of pixels. We don't need this. Please be patient there anymore, and this should actually work. So now we have this formatted, and then we have our progress bar here as always, and now we are going to camera h size, and here we are going camera.vsize, and essentially we are rendering like we did before. We are telling our we are now using our world here, which is called world here as well, which we created from the YAML file to render and to the camera to shoot a ray into this world and have the information. And yeah, this is actually, everything is here working out. Okay, so now what we need to do is we need to write it out to the correct correct image. So I guess the camera name would be a nice thing to use here. So we can format argument must be string literal. What did I do wrong here? Oh no, I don't even need this with print line. It works this way. Okay, nice. And now we are writing this one, and now we need to, I guess, yeah, right. And there we are. There we need a format now, which is then really based on the camera name. And it should be name here. And could not write. We could actually do something like now, as we are using anyhow, we could actually apply a context here as well and tell it that we could not write the output PNG. So this is the name to disk. And then we are simply returning or short-circuiting the error here. Let's format this. And after we have done this for every camera, we can write everything done there. And actually this should compile, even though it will not work yet, because we are not supplying information here. So let's see what happens if we run this. Run bin chapter 09 render YAML. So yeah, as it has no no world, no camera, nothing in there, it will simply bail out there. But maybe we should first of all output certain kind of information so that we can see that it did not match anything. So so let's maybe output some statistical information here. Going to render then the amount of camera perspectives for a world with lights. Or can we easily get this information? I'm not sure. Let's see. For a world with a number of lights, number of bodies, and bodies. And then let's have this. The camera perspectives, we can easily get the amount by simply asking the camera's hash map. Does it have a len? Yeah, it does have a len. Nice. So now we need world dot. Can we? I guess I can access this as I need to in order to render stuff. I hope that I can actually. Can I get the len of those? Yeah, and then world bodies dot len as well. So let's see. Let's format, and now we should get the information that we are going to render 0 camera perspectives for a world with 0 lights and 0 bodies. Yeah, that's that's absolutely correct. Okay, so now we need to take a look at how to get those information in here. Yeah, so let's Google that, I guess. Rust command line, no, command line, there it is, arguments. So let's click this and let's see. Accepting command line arguments sounds like exactly, yeah, exactly what we want to do. So I guess env-args is what we want to use. So let's use this one. So let's first of all have this here, let's call it args. And then let's call std env-args. And let's, as it is an iterator, let's directly collect it as we have seen in the example there before. Why doesn't this work? Why does it tell us that it needs a type here? Shouldn't it know it? Shouldn't it know that this will be... What does this actually return? Okay, vec string, so it needs to be specifically collected. Can't we do this here, like vec string, so that it... Okay, this would work as well. Okay, I'm not 100% sure where I want to put this, but yeah, the collect method does not know in which it should collect. But then, yeah, let's give it the type here as the example in the book tells us as well. So it's a vector of strings then, I guess. Yeah. Okay, now we have our arguments, and now we can have something like, let's do a little bit of sanity checking here. So if args.len, if it's not 1, as we are only accepting one argument now, I guess we should simply return an error with an anyhow and tell it that expected 1 argument but got, yeah, let's see how many we got. Args.len. Oh yeah, we need to import the anyhow macro, of course. Didn't I import anyhow here? There it is. So, oh, okay. So how did I do it in the YAML loaders to have this macro? Did I need to... Oh, I imported anyhow star. So the anyhow macro is there. Can I import this anyhow? Can I import it like this? Would this work? No, it would not. So wait a second, did I do something wrong here? It's not that mismatch type, expected unit type, found, enum result, anyhow, error. Yeah, but wait a second. Do I need a return here? Okay, why do I need a specific return here? As this is not the only branch. Yeah, of course. So it's not the last call in the function. So if we have a len which is not 1 of the argument count, we will simply need to bail out here. And let's quickly check if this is working. So if I'm supplying here like foo, it should work, hopefully. Expected 1 argument, but got 2. Okay, maybe we are getting the, let's expected 1 argument, but got 2. And let's maybe add those arguments there so that we can, vecstring doesn't implement display? Why not? Okay, so can we debug print it? I hope we can. So no, it's this way around. So let's check. Yeah, okay, this works. Yeah. So let's see. I guess maybe the executable name is in there. Okay, so so we need to accept 2 parameters here, expected 1 argument but got, and let's then have this -1 here because a normal user does not understand that the name of the executable is the first parameter we are given. Okay, so now this should, however, work. And yeah, it works. And if we don't provide it there, it should give us the error. Yeah, okay. So error, expected 1 argument, but got 2. Yeah, that's quite nice. Okay, so let's maybe print line something like. By the way, this is something I learned as well. Let's have a look. There is this this possibility of first defining raw strings in Rust, which are simply taken as they are without any processing, and you can actually have those strings with those hash signs here, and you can put an arbitrary amount of hash signs there, and the string is then multi-line and will only end once the hash signs are found there again. So what we are now doing here, or what I'm planning on doing here, is I'm simply, wait a second, creating this one and this one. And now I should be able to put in here a nice little usage. We will see if this works. Yeah, 1 positional argument there, and we want to put in there args0 then with the world.yaml, or let's call it World Yaml, so that the raytracer challenge renderer. The raytracer challenge renderer copyright 2021 Jacob best of, something like this, and usage World YAML, something like this, and so on. Let's call it the raytracer challenge Rust renderer, because I guess there are multiple others in other languages out there. So usage and so on, World YAML. Yeah, this looks actually quite nice. And let's see if this actually works. If I'm now not supplying this, yeah, we are getting those error information here, which is actually quite nice. So I like this. Let's leave it in there. And now we have this, and we have a little bit of sanity checking, and now we can, I guess, use here now args1 as a source file, and now we need, cannot move out of index, vec string, move occurs because value has type string. Yeah, of course, value. But I guess I don't need to move it out there. I can simply reference it because we are not writing it, we are only reading it, so a reference is fine. It's perfectly fine. So now, how did we, or how are we reading actually a file? That's something that's quite interesting. We are writing a file here, so there is this write function. I guess maybe there is a read function as well. So let's check this, I guess. I guess this is exactly what we want to do. Yeah. Sounds actually quite right. So fs read to string. Yeah, that's what we want here. So let's use this, I guess. Fs read to string and put our source file in there, and then we would, I guess. Yeah, we need to import fs, or let's directly import this one from std_fs read to string. Yes. So now what we need to do is let's see. But I want to attach a context here as well and say, okay, could not read world file. Yeah, I need a format here. Sorry that I'm so like this, and oh yeah, I should end the string. Could not read world file, world YAML, I guess it should be. or world files, right? All right, and then we put in there the source file as well, and now this should work. Yeah, and now we are expecting and now we have something here which we should maybe correct. I didn't know that when I wrote this one, but there is, as you have just seen here, there is something like this AsRef trait, and actually this is quite nice. Here we are expecting something that can be referenced as a path, as a it's a struct as well, but what we want to do is, here in this case, actually, we want something that is AsRef string, and we cannot explicitly supply it here. We need to create a template for this, but let's do this, I guess, because we want this one to be AsRef string instead of a direct string there, and this should actually, shouldn't it? Why? Oh, there is come on, there's the bracket missing. So now we need to adapt this one here, of course, I guess. Where are we implementing it? It's down here, yeah. And now we need, of course, to implement it here as well. This is AsRef string, and we are now doing this one here, but everything else, oh no, it does not. So mismatch type, expected reference string. So this one actually wants this here as, so let's call AsRef on it, and everything should be fine. So yeah, now we can put in everything that can be referenced as a string into this. So now we don't need to convert something here anymore, and it just works, which is actually quite nice. So yeah, I guess let's format this and then create an example, some sort of world definitions here. Maybe we should put them in not in shared, but in, I guess, let's create a new folder and call it worlds or something like this. Let's create a folder here and call it worlds, yeah. Or scenes. No, we always called this one world, so why not? So now let's have a look. Let's create, where is it? Worlds. Let's create our, I guess first one, which could look exactly like the one before, so that we have a way of telling that everything is working. So let's call this one 3 spheres and a floor.yaml. We can close this one for now, and we will leave this one open. This one can be closed as well. This one shouldn't have, oh, it has an error down here. What did I do here? This one is now, I've watched up the test. What did I do there? There's something wrong with the... yes, because the source is now... I guess I need to do it like this. Oh no, why not? Okay, what is not correct here? The trait bound AsRef string is not satisfied. The following implementations were found: str, AsRef, ostring, str, AsRef, and so on, and so on, and so on. Oh no, I guess I did. Yeah, no, this what I did there was not 100% right. I had it specified as a reference to a string object, which is of course not right. We want it as a reference to an str, which would make things easier for us, as we can nearly transfer everything into an str as a reference. So this should now work. Yes, it's working here now, and it should be working here as well. Let's see. Where did we do it? Up here somewhere. Yeah. So this is okay. Okay. So, but now we can close this one, and we can close this one. We can close our WorldLoader here. And I guess I want to split this one up to the right side, so to have it there. And now we need to more or less transfer over all of the
information we have in here into our new YAML struct. And yeah, I will do this I will do this quickly, and then we will see if it's rendering the right thing there. So this should be it. We should have defined now our whole sphere as we had before, with a light, a floor, a left sphere, a middle sphere, and a right sphere, and our camera here with the same dimensions and same positions, and we actually calculated those pi values here. Maybe we need to take a look at this in the future to have something like easy expressions there, so that we could actually write there pi divided by 3, but we will see this. This might be interesting as well in order to define animations with those world files, but we can't do this at the moment. It's not that problematic. Yeah, let's see, I guess, if this world file produces the same output that we already have here. So the one we have here, we rendered it at the beginning of the session, is this one, and we should actually be able to now create or recreate this scene exactly with our YAML file. So let's see if we can do this. So cargo run -- binary, which is our chapter 09. How did I call it? I've already forgotten it, which is not a good measurement for having a good name there. So it's not a good sign. So render YAML. And now we want the release mode, and we want to provide worlds, 3 spheres, and a floor YAML. And let's see if this is rendered. And it's building. Fingers crossed. Okay, so error, tried parsing worlds, and so on as YAML world definition, but failed. Tried to get value with key type from hash at 0√3 body type. So did I forget a body type somewhere? It seems in the third object it can't find the type, which is quite strange, but let's check. So we have the 0, 1, 2, 3. 0, 1, 2, 3. So it should be here, and it tells us that it can't find the body type here, but there is a type. So this is kind of strange. Maybe our renderer or our parser is still not correct. But it tells us, yeah, it's body.type key not found. Value with key type from hash. So what I'm not 100% sure that it try to wander down this type element, and that's kind of strange. Maybe I actually guess that there is something else wrong. That there is something wrong with the the parser path error messages, which seems to be missing that it is visiting a material here, because there actually is the type missing, and I need to add it here as well. So let's have a type here called font. Actually, I'm missing it here as well. So I guess there is an error in our parser there, which creates those paths, because there seems to be a dot material missing, and there shouldn't actually be the type here. There should actually be body dot material, and then it should tell us that it can't find the type. So there is something wrong there, which, well, I will take a look at this afterwards, but yeah, it's good that we discovered it. So now let's try and re-render this, and as you can see, it actually read those definitions now, going to render 1 camera, perspectives, for a world with 1 light and 4 bodies, and it's created our main camera PNG. So let's open up the main camera PNG, and it's actually exactly the same scene. So our parser works fine and created from, where is it? There it is. It created from this definition here. It created this scene, which is kind of awesome, I guess. So and it named it correctly, so I could, for example, create a second camera here. Let's quickly try this just for fun. Let's call it like second camera, and maybe change its position. Like we could have it a lot lower, for example. Let's put it there and put it a little bit to the to the right there, and let's see. Now it should actually render two scenes where a second camera is, which is positioned a little bit different. So let's see. Yeah, it rendered two scenes, perfect. And let's open the second camera here. Yes, and as you can see, this one is a lot lower positioned and it's a little bit moved over to the side. And this actually looks kind of awesome, I guess. I like it. And maybe we could even make it look up a little bit more. So let's point the camera up. I'm not 100% sure that maybe we should then go to like even further down. Let's see, and let's render again. Let's see what the result will be. But as you can see, it's now very easy to define those informations here, and it's a lot easier to read in this format than it was before in this. Oh yeah, a little bit too steep, so we don't see the the floor anymore. But it's kind of a nice view as well. Yeah, of course we don't see the floor because we are looking up now. It makes perfect sense. So let's revert this again because I like the second one, which I guess I will comment. Camera further moved down. Just to see that we can actually have different of those cameras here. We can have this in the YAML file. And we could easily... what should I say? We could easily maybe change the color of the spheres here a little bit. Let's start with the left one and change those colors to be a little bit more bright. Let's see what colors would be nice here. Something like this, I guess. Why not? So let's make the first one a bright and shiny violet color here, which is 1620255. So 162 would be 162 divided by 255 would be 0.635. Okay, so 0.635. Then there was a 0 and then there was a 1. So let's have this one there and maybe make the little the middle sphere make it really shiny instead of really glum we had it before. So let's make it like 8,000 shiny here, and it has a much bigger specular now, and it has maybe a little less diffuse lighting. And let's see, and let's adapt its color. Let's make it, yeah, why not? Let's make it pink. So we have 255, 0, and the same value we had here before. So we have a 1, we have a 0, and we have this 0.635 maybe. So yeah, and let's the right sphere. What should we have the right sphere? Let's make it, yeah, maybe blue. Blue looks nice, I guess. 0. Where is it? There's the right sphere. So we have 0. We have 0, then we have this 0.635, and 1 here. And of course we could easily adapt our parser to have different color formats here, for example. I could allow, for example, the hex notation, something like this there as well. And maybe I will implement this in the future to make things easier to define. But for now, let's render this again and let's see how our colors are popping. I hope that they are popping. Let's see. So we are rendering both scenes there, both camera perspective, and let's open up the second camera first because I like the dramatic effect of it being lower. So yeah, this actually was quite nice, but I somehow messed up this sphere here. It's still not very reflective. So let's take a look at this. Let's what did I do there? I had this left sphere, no, the middle sphere, sorry, and I had this diffuse value set to 0.4 and the specular value to 0.3, and I'm not 100% sure what the defaults are. So let's take a look at the defaults, I guess. Where are the defaults? There is somewhere, there is a Phong material there. Is it part of the material implementation of Phong. There it is. So the default values are an ambient of 0.1, which we actually did not override here. Diffuse of 0.9. So this is something I should maybe change. And I thought this would be quite specular, but then let's make it like 1.5, or why not double it, 1.8, and let's see what happens now. So let's re-render it. Oh no, I didn't want it to open it, I wanted to re-render it. So let's quickly re-render it now and let's see. And I hope that this will look quite awesome. So yeah, let's see, and open this one up and open second camera. Yeah, now it really pops. But it doesn't have this big, that might be the shininess, yeah, because now it's a really harsh and not very diffused reflection there, which doesn't look that nice. So maybe we can change this back to the default, and let's see then. Oh no, let's render it first and let's see then. But as you can see, it is a lot easier to play around with all these values now, as we have this this definition file here, which I quite like, because it makes things for us easier in the future. And I have, yeah, now it's really reflective. That's nice, I like that. Now it's really popping and it's really reflective, and yeah, I like that. Let's have a look at the main camera, the other camera angle, yeah, which is even more popping, because it is directly more looking from the direction of the light, so it's more light is reflected into it. Yeah, so I guess this looks quite nice, and I like it as a result for this yeah, for this session. So now we have actually the possibility to define our scenes, our worlds, as a YAML file, which is really nice. And I guess I will in the future invest some more time in this, maybe on camera, maybe off camera. I'm not 100% sure there. To, for example, as I've said, allow proper or other formats of color here, or especially to fix this error where we didn't get the right path. I need to get down to this in a calm minute, and we'll then take a look at this and fix this. As always, you can find all of those things here in my GitHub repository. Links are, as always, in the description below. I want to thank you for joining me again for this installment in the raytracer series and this video, and I hope you enjoyed it as much as I did when creating and writing this stuff, as always. If you are interested in being informed once the next session comes out, please hit the subscribe button and the bell next to it in order to get a notification from YouTube once the next session is out. And please hit the thumbs up if you like this video, because this helps me a lot to, first of all, see that you are really interested in this, as well as having it found by other people, because the YouTube algorithm works like this. As more and more likes are there, more people see this stuff, which is great, I guess. If you have any questions, or you want to comment something, or as some other people did, want to give advice on some things I do here, please don't hesitate to drop me a comment as well, and I'm gladly responding to those and reading those and having fun interacting with you. So I hope to see you in the next installment, and yeah, see you then. Goodbye.